Okay, Bismillahirrahmanirrahim. Assalamualaikum and good morning, guys. So today I'll be continuing our class for orthographic projection. Okay. So before we proceed, I hope you have mastered whatever knowledge or subtopic that I have taught you guys. So we still have another two subtopic, which is the orthographic projection and the floor plan. Okay, floor plan actually is related to architectural drawing. Okay, nevertheless, as part of the course outline, so I have to complete this floor plan subtopic. Okay, normally when we have a building layout, we can see the elevation of this building, for example, from the left and right, and from the front and top. Okay, uh, however, if you want to understand the flow of discharge of the wastewater, okay, for example, the flow of the smoke emission from your chimney, so you need to understand the floor plan of machines and your manufacturing line. Okay, but that will be covered on the next class. But today, I'm going to share with you on how to start with photography projections. Okay, so I'll be sharing uh, lecture notes from this e-learning platform. The topic is orthographic. Okay, orthographic. Normally, when given shapes in 3D, sometimes you will be given in isometric drawing. So from the isometric, you have to have some imagination on how to extract this shape into a photographic projection. Okay, so we'll be downloading this channel. So I don't want to download mine from the OneDrive. Sometimes the one that I have been uploaded in the e-learning is suitable to you. Okay, IEA216. Okay, now I can switch my role as a student so that I can see same like you are seeing. Okay. So we can see from my topic here, orthographic projections. Okay, lesson 3. At the end of the lesson, student will be able to draw orthographic projections. Okay, I suppose it should be uploaded already. Nevertheless, never mind, I can upload it now. Okay, because okay, so is it? This is it. The lecture notes for orthographic projection. Okay, never mind. I can upload it now for you so that you can browse through it. It should be here at resources, file, orthographic. Okay, and I can drag it here. Okay, it has been, I put it on top of it. Okay, so you can see it. So while you are doing this exercise, you should be able to download the lecture notes. Okay, so orthographic projections. So for the CLO, you need to understand the definition of orthographic orthographic into the drawing. Actually, orthographic is a projection that you extracted from isometric drawing. Isometric, we can say that it's a 3D drawing because you have x and y axis. But when you are dealing with these orthographics, you only play with the x and y axis. Okay. The important thing is the angle of inclination to start to project these shapes. So you should be able to draw a 2D drawing from a given shape project based on isometric view, and you should be able to measure 3 different views from a given isometric drawing. Okay. So actually, orthographic projection is a method used in the production of engineering products. Okay, to illustrate where the shapes and dimensions of the various forms of revenue from this engineering field. So if I want to take an example, let's say I'm having this. I want to give a very simple shape. Okay, like this mouse is a has curve, right? Curve inside. So when you can see it, you can see it clearly in the 360-degree view, right? Just your eyes can see 360 degree, right? If you are project it from the isometrics, the shapes maybe come in terms of the 3D like this, and you will going to see from the bottom or from the top. So from this given object, if you want to see it from the front, so you need to imagine the shapes from its initial view, okay, in the 3D form. So for the front view, you can see this, for example, the Logitech. So for the front view, you should be able to see a curvy shape. Okay, it's not a rectangular, it's not rectangular, it's not square. You see, it has curve here, right? So this will be the front view of your projection. So from the given shape of the 3D view, you should be able to transfer the image into the 2D form. Okay, and you can see from the side. This is the side view. You can see it, okay, here, curve, right? If I see from here, from the right hand side, I can see another curve here. Okay, that we call as orthographic projection. If you can see from the top, okay, so I move this mouse uh, top view. You can see this is the view. If you project it is like this from the back, this will be your back. This is the front view. The remaining or the maintained dimension will be the width. Okay, width. Okay. And this is the height. The height you can project it here. Okay, uh, from the top you can project it outside. Okay, and you can take this width of the mouse on top of it. Okay, you can have the top view. Okay, so what we need to know, we need to ask ourselves what is the orthographic project, and basically is a way of representing 3D object on a piece of paper. Okay, right now you are seeing it in the 360 view, okay? You can see it clearly. Okay, you can turn it upside down. Right? The idea, okay, wait. This means we make the object to become 2D. The difference between orthographic projection and other drawing methods is that we use several 2D views of the object instead of single view. Okay, so can you distinguish it? Right. For example, I'm showing to you in the lecture notes is a box of television. So this is an old school television. Okay, the TV screen. So if you have to see from E, the elevate E means that the front view of this television. Okay, and if you want to see from the opposite, I mean the side view of this television TV screen, you can see from the right hand side, or you can either see it also from the left hand side. The P is the plan view or the top view of your screen. So the E projection is here. Okay, very important. The P, the plan view is here top. Okay, and the E, the front view. the television. So we are looking at this view, the the front view. We could not see what is the inside or behind this television screen, right? Actually, we can see it from the top and the side view. Okay, so this is it. This is the front view. This is the top view, plan view. This is also the elevation view or side view. From the right hand side, you see from the right hand side, and for the left hand side is from the left. Okay, now the idea, orthographic projection gives us a very clear methods of communicating ideas and objects. Okay, I hope my screen is recording. Okay, let me check. Okay, it's still recording. Good. We continue. The idea for this orthographic projection is a method that every engineer in the world recognize. Okay, but I don't want to say that this is all traditional way, but basically, like me, I learned my engineering drawings from the drawing box, not like this. Okay, for engineering school, uh, we were being taught to use a drawing block manual. Okay, we were taught to bring our drawing block, the T or I square together with us. So we have a specific type of pencil and few geometry shapes for us to drawing. So we have been exposed to that level first before we come to the AutoCAD drawing. So we appreciate more on the machine drawings, the electronic engineering drawings, and the civil engineering drawings, because we have to use our bare hands, not like what we are learning now. For us, because we are technology students, so only it should be enough for just the application of this software. Okay. At the end of the day, regardless whether you have been exposed to the drawing block uh, in traditional way or by using the AutoCAD, the important thing is how do you understand or read the plan. This is important. Now, I'm showing to you this is a project of mine. I can share with you later on in the file in the screen. So this is the okay, the actual architecture plan for you to understand as hopefully you can be an engineer. Hopefully, never mind. If you are normal people, if you're not working in the engineering field or technology field, it's okay. You still should be able to understand or read the plan given. Okay. Now, macam ni. Okay. This is the printed A1 layout. So let me check the project first. Let me walk you through the project. So this is a factory I'm dealing with for I mean for the glove latex glove making latex glove manufacturing facilities in Penang. So I'm one of the consultants for the environment. Never mind, I want to share with you how do we read the plan. Okay. Okay. Oh no. Okay. The layout. Yes. Okay. This is the process flow related to you. So this is the layout. Okay. Now, if you want to understand this, okay, so this is the floor plan of the manufacturing line. Okay. Can you see it clearly? You see from the bird's eye view. So when the roof has been removed from the building, so you can see what is inside of the factory. Okay. I don't want to discuss on this because this will be later on be taught. Okay, Yani. Okay, this is the Keratan AA and CC kiri. Keratan AA is a section, the cross section of the building. So let's say we cut off from the floor plan here. So you see the AA cross section, you can see from the inside of that building. Okay. So this is the AA section. So we can see this is the cross section, the half cut of the building. So this is the roof. Okay, this is the roof. Nampak tak? This is the manufacturing line, 12-meter height for the glove making facilities. This is for overland drainage. Okay, this never mind. You don't have to master it. And this is this pandangan sisi kiri, the elevation, left side elevations of the building. Okay. What you need to know is the cross section will show you what will be inside that facility. Okay. So this is the glove manufacturing line. Okay. Uh, let's say I'm open on the type of project. I have plenty of projects with me. Let's say we have building for mm, okay, this is the layout of a project. Okay, so as an engineer, later on, if you've been exposed to the construction industry, you should be able to understand how to read this plan. Okay, so this is the location plan, the key plan.